Hello everyone, my name is Junisa and my matrix number is 1810912111. So the title that I'm discussing today is the active power and parameters of a three-phase system. So before we go into introduction, let me briefly talk about this experiment. So in this experiment, we got to know the parameters of a three-phase system of a Y-connected three-phase generator connected load. So in this experiment, we also get to know the active power of a system through the 2 wattmeter method. Besides that, this experiment also allows us to evaluate if the parameters of the three-phase system is under the acceptable voltage drop based on BS 7671 or any Malaysia's authority standard. And in this experiment, we also get to use PSIM software. Okay, so that's all. So we proceed into introduction. So in introduction, the three-phase system is a system which has 3 phases and it uses 3 wires for generation, transmission, and distribution. So there are 4 wires in total. So another one would be the neutral wire. So the sum of the line current in the three-phase system is equal to 0 and their phases are differentiated at an angle of 120 degrees. So the cross-sectional area of the neutral conductor is half of the live wire. So the current in the neutral wire is equal to the sum of the line current of the 3 wires and consequently equal to a square root of 3 times the 0 phases sequence components of current. So power consumption can be measured by the line-to-line voltage of the 3 pairs of wires. Besides that, the 2 wattmeter method measures the current in 2 of the 3 lines and 2 voltage from the said lines with respect to the third line. And from there, the total power of the lines, regardless of the balance of current, voltage, or load variations, can be accurately derived. So both three-phase system and 2 wattmeter method are being used in the experiment. Okay, so let's go into the objectives of the experiment. So we have 3 main objectives, which are to measure the parameters of the three-phase system, to measure the active power of the three-phase system by using the 2 wattmeter method, and to understand the usage of PSIM software in the experiment. Okay, let's go into the methodology of the experiment. So we have several steps being done throughout the entire experiment. So firstly, we determine the introduction of three-phase system and 2 wattmeter method to know more about these 2 methods. Then, we determine the data from three-phase system and 2 wattmeter method. Then, I construct the three-phase system by using the PSIM software. After that, I run the entire simulation. After running the entire simulation, I get to obtain the data from the simulation by using the PSIM simulation. After that, by using the data provided, so the calculation is being done. After that, the data are being inserted into the tables and compared between the calculated values and the measured value by using the PSIM simulation. After that, discussion and conclusion are being done after the entire calculation and the result are being drawn. Let's go into the calculation part. So these are the calculations that are being done in the experiment. So the data that I've received are the rated line voltage is 11k voltage and the transmission loss is 11 plus J12 ohm, while the load would be 81 plus J09 ohm. So in the calculation part, we calculate the parameters of the balanced Y load connected to a 3-phase Y connected generator. We determine the phase voltage, determine the line current, determine phase voltage of the loads, determine the line voltage of the loads as well, determine the active power, determine the voltage drop percentage, determine the load power factor, and lastly, we determine the inductance of the load inductor and transmission loss inductor, which are being used in constructing the circuit in PSIM software. So let's show you the PSIM circuit. So the circuit that I've drawn in PSIM software is this, and these are the data that I've received after running the entire simulation. So you can refer to the data on the right side. So these are data that I've received after I've run the entire simulation. So let's go into topic. So for the result and discussion part for table 1, where we discuss about the result of the calculated line current and the measured line current. So this is the graph being received after the simulation being done and the data being received after the simulation as well. So we can see the calculation of the line current where you determine the line current. So you can see the data for line A, line B, and line C are of the same, which are 67.29 ampere. So for the measured line current, line A, the value is 67.33 ampere, while for line B is 66.35 ampere, and for line C is 66.17 ampere. So what we can see is the value of line current of A, B, C are of the same for the values of the calculated line current. So there is a slight difference between the values of calculated line current and the measured line current, which are using the PSIM software simulation. So the value of the calculated line current for line A is less than the value of the measured line current for line A, while for values of line B and line C, the calculated line current are higher than the measured line current. Let's go into table 2. So in table 2, we discuss about the calculated phase voltage of the load and the measured phase voltage of the load. So this is the graph being obtained after the entire simulation, and the data are being obtained as well. So we take a look at the calculation. So we determine the phase voltage of the load, where you can see the calculated phase voltage of phase A, phase B, and phase C are of the same, which are 5.48 kilovolt. So for the measured phase voltage for phase A, it is 5.49 kilovolt, while for phase B, it's 5.44 kilovolt, and for phase C, it is 5.43 kilovolt for measured phase voltage of the load. So in table 2, we can really observe that all the values of the calculated phase voltage of the load are of the same, which are 5.48 kilovolt. So there is a slight difference between the values of the calculated phase voltage of the load and the values of the measured phase voltage of the load, which are being obtained from PSIM software. So the values of the calculated phase voltage of the load for phase A is lower than the measured phase voltage of phase A, which is 5.49 kilovolt. Whereas for phase B and phase C, the calculated phase voltage of the load are higher than the measured phase voltage of the load. Let's go into table C3, where we talk about the calculated line voltage of the load and the measured line voltage of the load. So this is the graph being obtained after the entire simulation, and these are the data being obtained as well. So you take a look at the calculation part. So in the calculation, you can see for phase A, phase B, and phase C, the calculated line voltage are of the same, which are 9.49 kilovolt, while for the measured line voltage in phase A, the measured line voltage is 9.48 kilovolt, while for phase B, it's 9.38 kilovolt, and for phase C, it's 9.47 kilovolt. So what we can see in table 3 is all the values of the calculated line voltage are the same, which are 9.49 kilovolt, and there is a slight difference between the values of the calculated line voltage of the load and the value of the measured line voltage, which are being obtained from the PSIM simulation. So all the values of the measured line voltage are lesser than the calculated values of the line voltage. So we go into table 4, where we discuss about the calculated active power and the measured active power. So these are the graphs being obtained from the simulation, and these are data being obtained. So by looking at the data being obtained, so active power can be calculated by adding 0.517 mega plus 0.565 megawatt, which is 1.082 megawatt. So the calculation is being done, and refer to the calculation, the value of the calculated active power is 1.099 megawatt, while for measured active power is 1.082 megawatt. So in table 4, the value of the calculated active power is different with the value of the measured active power. So the value of the calculated active power is slightly higher than the measured active power, where it shows that it is the active power absorbed by the load. So next, we talk about the voltage drop percentage. So based on the calculation, the voltage drop percentage is 13.70%, which has exceeded the range of voltage drop percent voltage based on BS 7671 or any Malaysian authority standard, which is 3% only. Okay, so in conclusion, there are slight difference in all the calculated values and the measured values. So there are slight difference in all the values between the calculated value and the measured value in the current phase voltage of the load, line voltage of the load, and the active power. So this is because of the number of decimal places that we use in the calculation, and also the number of decimal places used in calculation will affect the final value that we receive after all the calculations are being done. So this is also because there is a lagging in the inductor in the three-phase system. And another discussion is being drawn that the voltage drop percentage in this experiment is 13.70%, which is not within the range of the voltage drop percentage based on BS 7671 or any Malaysia's authority standard, which is a maximum of 3%. Hence, all the objectives are being achieved in the experiment. That's all from me. Thank you.